Okay. So we have our mechanical energy, kinetic. Oh, sorry about that. We have our mechanical energy webquest. All right. So mechanical energy is going to be right here, the sum of both potential and kinetic energies that an object has. Now, for a given system, an isolated system, the mechanical energy is going to be the same no matter what. So, for example, if I could show you this on a simple drawing, which I'm gonna do because I'm awesome. Shush. All right, so we have our ground down here. We have a table. All right, we have a ball that's being basically just chilling right here. Now, it's being held in place for a second. And if I told you that the potential energy here was 100 joules, and that it's at rest for a second, it's not moving, what does that mean the potential energy has to be? Based off of what we said yesterday. Kinetic energy means the object has to be doing what? Moving. So if it's at rest right here at point A, if it's at rest, what is the kinetic energy there? Gotta be 0. Now, if I let this go, what's going to happen? What is gravity going to do to the ball? Yeah, it's going to cause it to fall down, right? So as this thing falls, what is happening to the height? The height is decreasing, right? So potential energy is mass times gravity times height. Kinetic energy is 1/2 mv squared. And there's a thing for mechanical energy. So mechanical energy for a system, mechanical energy, ME, is the sum of both potential and kinetic. So once you know what the mechanical energy is at one spot, it's the same for the whole system. It's like it's going to be constant. That value won't change, but these two can. So right now, potential is 100, kinetic is 0. What would my mechanical energy be here for at point A? Would be 100 plus 0, so it would be 100 joules. So that means no matter what, at any single point along this fall or along this portion of motion, kinetic and potential have to add up to be 100. No more, no less. So let's say it falls and now it's here at point B. So if I said here at point B, the potential energy is 60 joules. What would my kinetic energy be? Well, if I just asked that, you'd be like, I don't know. Well, here it was 100. Here it was 0. Mechanical energy, you add the two values together, you get 100. And then that is the same value for the whole way through, for the whole system. So, yeah, it would have to be 40. Good. Because 60 plus 40 would equal 100. It has to be. Let's say here at point C, the kinetic energy is, let's say, 55 joules. What would the potential energy have to be here at C? 45. Right, because 5 plus that would be 60, 16, 40. Good. And then now at the very, very bottom, so this is like a normal kind of problem that you'll see for any kind of physics thing. At the very, very bottom, let's call this at point D. What is the height? So it may be worded like as the ball touches the ground. Like right as it hits the ground, or right before it hits the ground, what is the height going to be? Okay, 0. So because of the equation, mass times gravity times height, if height is ever 0, the potential energy is 0. So here, potential energy would equal 0 joules. And what would that mean the kinetic would be? Yeah, would have to be 100, because still at this point, they have to add up to be whatever the mechanical energy was. And if that was 100, that is what's going to have to go about. Now, if I gave you the mass of an object here, if I said the mass was a certain thing, you'd be able to tell me the potential energy, the speed. You'd be able to tell me a bunch of different factors. So let's just say, pick a number for me. 7. I was wow, that's actually creepy, because I was thinking the number 7 in my head. That was really weird. Did you just Oh, so you wanted the superpower to read minds, so you just read my mind. Okay, I see where you're at.
I think I might be a good lawyer. I'm good at reading minds.
I don't know if that would make you necessarily a good lawyer, because it's not about what you know, it's about what you can prove. Anyway, we digress. So let's just say the mass of this object was 7 kilograms. If I wanted to know what the speed is at point D, all right, so what is the speed at point D? Speed or velocity at point D. Sorry, my handwriting is a little sloppy right now, guys. So what do? Kinetic energy is the one that has velocity in it. So what you would do is you would set the equation up. And now you know what the kinetic energy is. It's 100. And you know what the mass is, 7. The 1/2 is constant. So we're going to write 100 here times 7 times v squared. So what's 1/2 of 7? 3.5. So we have 3.5 v squared is equal to 100. So to get v squared by itself, you got to divide both sides by 3.5. So let's see, what is 100 divided by 3.5? That's roughly 28.5. So we have 28.57, called the 2 decimals, is equal to v squared. How do I get v by itself? It's squared, right? So to get rid of a square, you need to square root it. And whatever you do to one side of the equation, you have to do the other. So when we do that, we square this, that gets rid of this little v. Or it gets rid of the squared part and just leaves us with v. And we have to square root that number. So then I'm going to do my calculator. Square root. And this comes out to be approximately 5.34 meters per second. Now you could do the same exact thing at any one spot. So if you know what the mass is and the kinetic energy, you can just do this and tell me and figure out the speed or velocity. Okay? Now if you wanted to know, here's a really cool thing for potential energy. You see potential energy is right here, the MGH. You guys know the magic triangles, right? That we've used. But normally they've only ever had 3 variables, right? Well, we can have potential energy up here, that's in joules. We have mass, which is got to be in kilograms. Our gravity, which will be in meters per second squared. And then height, which will be in meters. So, if I asked you, to solve for height, what would I do? Still the same thing. You still cover up, all right? You would still cover up the variable. So let's say I'm solving for, I want to know what h is. If I want to know the height of something, if I cover that up, what is going on inside the triangle? Potential energy divided by, now if they're next to each other, you multiply. So if I want to know what the height is, I cover that up. So it's potential energy over mass times gravity. Now, what value are we using for gravity? We're using 10. If someone's using 9.8, they can use that. But that would be that. That's how you can do that. Now, if you knew how high it is off the ground, and you knew the potential energy, and you wanted to know what mass is, the mass would be this. Potential energy divided by gravity times height. And if I wanted to know potential energy, if I cover that up, mass times gravity times height. Okay. Now, if you know what the speed is, and they want you, and the mass, and they want you to find kinetic energy, you only square the speed. You would only square the speed, then times it by the mass, and then divide by 2, and boom, you have kinetic energy. And all energy is measured in joules. Okay, so with all of that being said, let's go back. So what you guys will do is, for this web quest, you can do a quick search for a definition below for these guys. Okay, so we'll come back to that. You guys will be able to do that one quick, easy on your own. All right, so but let's stay with this guy over here. So explore the link here. We're going to look at a virtual ride of Cedar Point's Top Thrill Dragster. It's going to be a roller coaster. So in this little space here, we're going to make a sketch of the roller coaster, and then we're going to label points at which the coaster has the greatest potential energy and the greatest kinetic energy. Now, before we do that, we look at this drawing here. When was potential energy the highest? If you look at this drawing in here, if you're looking at, nope. If you're just looking in the green, where is potential energy the highest? At point A. And where's point A? Is point A the highest or lowest? Highest. So gravitational potential energy depends on the position of the object. The higher it is from a surface, all right, in this case the ground, the greater the potential energy is going to be. So where do you think the most potential energy is going to be on a roller coaster? At the very, very top. Okay, good. And then where do you think kinetic energy would be the greatest? Yeah, it's essentially the opposite. All right, cool. Cool beans. All right, so let's click and let's watch. All right, it's only a short little video.
Oh, that's an actual roller coaster?
Yeah, it's an actual roller coaster. Now the video may be looking like it's a little lagged. Oh, really? I got like sick just watching this video before. I hate roller coasters, by the way. I love roller coasters. I would love to love roller coasters because I'm a physics teacher and there's also crazy kinds of physics behind it. But I also hate them.
Me too.
Why?
Afraid of heights, and I hate the feeling that you get. A lot of people might like that feeling. I'm not a fan. Ready, set, go. Ready, set, go. Ready, set, go. All right, I was close. Damn it. Dude, that thing is blasting off. Oh, nope. Nope, 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 nope,
That was it?
That's it?
Well, hey, Kinder Ka is just about the same thing, except it goes super, super, super slow on the way up, and then it's like, it hangs you there for a second, so you look around, and you're like, holy crap, I'm up wicked high, and then it's just like a drop of the loop.
I've been on almost every ride.
Not a fan. All right. So here it wants us to provide a sketch of this roller coaster and what the track looks like, and label the points at which the coaster has the greatest potential energy and the greatest kinetic energy. All right. So what you guys are going to do is you're going to double click on this box here, and it opens up Google Drawing. Then you go where that little line feature is. So we're going to sketch this out. So you double click on the picture. It brings you to the drawing, and then you're going to go to where it says that little line, but you're going to click on the drop down box and go down to scribble. 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 All right, so how did it basically start? It started up,
Straight and then just.
yeah, it was like this. It went up, came down. You don't have to do the twisty or whatever, and then down like that. Now, yeah, that shouldn't technically be there. But you know what? We digress.
Oh, I can't do this.
Listen, it doesn't have to be great.
No, like I literally can't.
Why? You can't do that motion? You can't just do woo?
No.
Okay. Yelling. Okay, so we have to label the points where it's the highest potential energy. Where is that going to be again? The top. So I'm going to make a quick little circle thing there. And I'm going to write P. PE, that's where it's the highest. And where's KE the highest? Down here at the bottom, somewhere. Oh god, that's an off circle. Oh boy.
You do realize you can just do the shapes of the circle, right?
Yeah, I know I could do that, but now.
Oh,
Oh boy,
I did it.
that's a
Oh,
very
no.
good. That's so amazing. Okay, so you guys, once you get it to look something like that, you're gonna then save and close.
Wait. I was trying to make it look pretty.
You don't have to make it look super pretty.
Okay.
It's okay. Okay.
Now I don't know what to put.
Potential energy is at the highest. Kinetic at the lowest. Huh? Okay, here you're going to go on this website, click on it, watch a video, and based off the video, you guys will watch this on your own. Little Wile E. Coyote and Roadrunner, old cartoon, has gravitational potential energy, elastic potential energy, and kinetic energy. All right. So you guys will watch that on your own. You'll write the definition based off the video, and then do a research quick of the definition. 4, you're going to do this little, click on this link, you're going to do this tiny little quiz thing. All right. It's not crazy. It's not super difficult. It's good, though, because it does give you guys a couple different kinds of questions to take a look at. Okay, can I go back? Can I go back? Okay, well, I can't do it right now because I guess I already had done it. And so it's telling me now I can't again. But you go through, you do your best to answer those questions, and it says, okay, then write down your score. There's like a total of like 6 questions to do. You can write, if you get 3 right, write 3/6. If you get 5 right, it doesn't matter. You're not going to get points taken off for that, but try your best anyway. 5, you're going to illustrate this thing the best you can and label 3 points where the potential energy is the greatest. So instead of having to try and draw and sketch this, because that would be a real pain in the feathers, yeah, we're going to screenshot it. So when you open that up, Come on. Okay, we can hit launch real quick. And now to screenshot, I can't tell you guys how to do it on your computer, right? But now here, look at the play button. Now, red is going to be potential energy, blue is going to be kinetic. So if you hit play, look how the potential energy gets big. It's at the highest at its very height. Okay, so you saw that the kinetic energy was the greatest down here, here, and down here. Potential energy was greatest here, and then here. Why? Because of the height differences. So the highest height would have the greatest gravitational potential, then the next, and then the next. So we're going to screenshot this. So on a Chromebook, it's Control, and I think the button is above the 6. It's like the box with the 2 lines next to it. If you have a different computer, you may have to like Google how to do that real quick. All right, I'm not 100% sure. On mine, I have a Control button, and then there's like a PRTSC. So I click that for print screen.
Can I draw it?
You can. It's going to be a little bit more of a pain in the butt, though.
Like that?
Actually, pretty solid. Okay. So then what I'm going to do is I'm going to double click in here. I'm going to paste it. If it loads a little bit quicker. Okay, so you see how it's down here? I'm going to drag this. Now, if you double click on it, those little black border arrows kind of show up. Now we can shrink it, and that crops it for us. Cool. Once that happens, then you can click on it, move it, bring it in, and try and get that to go as big as you can without it falling out of the borders. Now, it wanted us to label the points where we have the greatest potential energy. So you can make little circles here. At that point, at this point, and then at this point. Those would be the spots where we have our next best potentials. So point A, B, C. You can label them. You can make a text box if you want to label A, B, and then C. So it should vaguely look like that. All right. Now, you guys just make a note that I am recording this, so you guys can go back to look at it if you needed like a quick clarification. And then for 6, you do an internet search of real world examples to try and find mechanical energies, all right, of potential energy, galactic potential, kinetic energy. And you can literally type in Google, real world examples of gravitational potential energy. Then switch it out for elastic potential. Then switch it out for kinetic. You need 2 examples. And then the very bottom thing here, this number 7, Venn diagram. These words here, besides potential and kinetic, because they're already in their own spots, you kind of put them in their own positions.
Let me guess. If they're under the whatever first one.
Energy of position, that's potential. But a ball rolling off the table would be more what? Kinetic. Right? Like a ball sitting on a table, that would be, because it's not moving, then it would be potential. So cannot be created or destroyed, that's both energies. Law of conservation of energy, which is in both. Energy would go under both. Ability to do work would go under both. And you could probably even put waterfall under both, because right, like the water's starting up really high, and then it's also falling, so it's changing as it's falling. So because it's a pain in the butt, to double click on this thing. All right, you have your little Venn diagram that pops up. You can make your text boxes, but now I'm like, oh crap, I can't see the words that I needed to use. So let me close out of that for a second. Probably best off, guys, just on your phone taking a quick screenshot of this word bank, and then going double clicking in here and using, and then writing them in. That way you have like something to look at instead of having to go back and forth every single time. All right.